In the last case, so we had multiplied so 1 plus x to the power n with the itself. Here, the squares of the binomial coefficients. We have also seen many combinations, right? Like binomial coefficient. You can also use integration method to do this question. So that will be more complicated, right? The next property of the binomial coefficients is of the form c0 square plus c1 square plus c2 square up to cn square. Here c0, c1, c2, these are the binomial coefficients. Instead of writing NCR, sometimes we write it as CR, right? It is understood from the context. CR simply means NCR. So here NC0 square plus NC1 square, etc. So sum of squares of the binomial coefficients. We already know the formula for the sum of binomial coefficients. NC0 plus NC1 plus NC2 up to NCn, that has value 2 to the power n. Here the squares of the binomial coefficients. We have also seen many combinations, right? Like binomial coefficients combined with arithmetic progression, and similarly geometric progression, harmonic progression, the combination of an arithmetic progression with the binomial coefficients. Similarly GPHP. Now we have binomial coefficients combined with the binomial coefficients only, right? The square, right? C0, C0. C1, C1, this combination, right? So this should be done by entirely a different method. So there we used a different approach. Now here we have to use a different method. See, but again we have to use the same expansion, right? So we know that 1 plus x to the power n. So same expansion we've used there also to derive all these formulas. Like here 1 plus x to the power n. So that is nc0 plus nc1. Now we will simply denote it by c0, nc0, right? c1 x plus c2 x squared, etc. up to cn x to the power n. So this expansion we know already. Now here we write the same thing again, okay, but in the reverse order, or maybe you can write it as x plus 1 to the power n. What is x plus to the power 1? N. So nc0 x to the power n, right? So that means c0 x to the power n plus c1 x to the n minus 1 plus c2 x to the n minus 2. So like that. Last cn x to the power 0 or cn 1. Okay, now what we are going to do is we want the product of c0 with c0 only. That means you have to do the multiplication. We are going to multiply. If you multiply c0, c0, so we'll get it, right? c0, c0 x to the power n, and also c0, c1 x to the power n minus 1, c1, c0, c1, c2, c2, c1, c3, all combination will get. But we don't want all the combinations. We only want these combinations, right? The corresponding terms, right? C0, C0, right? Square. Similarly, C1, C2. How to separate those terms? If you just do the multiplication of all the terms, we will get all the combinations. Not only C0 with C0, C0, C1, C1, C3, C5, C8, all the combination. We don't want all the combination. We just need these values, right? C0 multiplied with C0. See, if you do this multiplication, C0, C0, C0 squared, x to the power n. Similarly, if you do the multiplication of this, there also we'll get c1 squared x to the power n again. So those terms which have x to the power n, so those terms we want, right? Not all the terms, only the coefficients of x to the power n we need. If you do the other combination, like if you multiply this and this, you get c1, c2 x to the power n minus 1. So we don't want that. We only want terms which have x to the power n, right? So the coefficient of x to the power n in the combination, right, in the multiplication is what we need. Okay, so what we are going to do is we will multiply these two and then take all the terms which have x to the power n. That means the coefficient of x to the power n in this multiplication is our required answer, right? So our required answer is simply the coefficient of x to the power n in this multiplication. 1 plus x to the power n multiplied by x plus 1 to the power n, right? Yes, we can't obviously write all the terms of the multiplication separated. Directly we will write only those terms which have x to the power n. This multiplied by this multiplied by this. So like that. Okay, yes. So let us do this multiplication. So we get c0, c0. X to the power n, right? Yes, we just need the coefficient, so we don't need to write this term, right? So only coefficient c0, c0 x to the power n plus next term c1, c1, again x to the power n, right? So these are the required coefficients. Finally we'll get cn, cn, last term. So that equals, so coefficient of x to the power n, this multiplication, what is this? 1 plus x, this is also 1 plus x, right? 1 plus x, 1 plus x. So 1 plus x to the power 2n, right? If you multiply, we'll get that. Okay, that's all. We just find the coefficient of x to the power n in this. So that is the required answer, right? The value of the squares of binomial coefficient, right? C0 square plus C1 square plus C2 squared, etc. up to Cn squared. So that equals the coefficient of x to the power n in this, right? So this expansion we know, right? So 1 plus x to the power 2n. So that is 2n C0, right? 2n C0 plus 2n C1 x to the power n. So that is the expansion, right? So that is the expansion 1 plus x to the power 2n. But from this, we need a coefficient of x to the power n. What is the coefficient of x square? 2n C2. What is the coefficient of x cube? 2n C3. So the coefficient of x to the power n in this is simply 2n Cn. So that's all. So that is the required answer. So this is the formula for you to remember, right? Sum of squares of binomial coefficient. Just like you remember the formula, the sum of all binomial coefficients 2 to the power n. Similarly, sum of squares of binomial coefficients, that is 2n Cn. So this is for you to remember as the formula. Okay, yes. Now similarly we can derive other formulae, like instead of finding coefficient of x to the power n, okay, see this is like one result which we have to remember. Now similarly, coefficient of x to the power n. Now similarly, what if you find the coefficient of x to the power n minus 1? If you find the coefficient of x to the power n minus 1 in the multiplication, so when will you get x to the power n minus 1? This constant term multiplied by x to the power n minus 1, it means C0 C1. Similarly, C1 C2, not the corresponding terms but these terms, like C0 is multiplied, first term is multiplied by second term, C1 multiplied by C2 and C2 C3 etc. So that means if you find the coefficient of x to the power n minus 1 in the product, so we will get coefficient of x to the power n minus 1 in this multiplication. Again same thing, 1 plus x to the power n multiplied by x plus 1 to the power n. Same multiplication, but instead of x to the power n coefficient, we find x to the power n minus 1 coefficient. Okay, what do you get? C0 C1 plus C1 with the C2 and then C2 C3 etc. That equals, I mean last time is Cn minus 1 Cn, that's okay. So this is same as the coefficient of x to the power n minus 1. So this is same as 1 plus x, again 1 plus x. So it is x plus 1 to the power 2n, right? That is same thing, right? 1 plus x to the power 2n, but we need this time coefficient of x to the power n minus 1. So here 2n Cn, so here it will be 2n C, instead of n we have n minus 1 here. So that's all. That is the coefficient of x to the power n minus 1 in this same product. Okay, so instead of 1 plus x to the power 2n, so same thing but coefficient of x to the power n minus 1. So this is the answer. Now using this we can directly write the answer, next one. So this is also a result which we have to, you can easily remember, right? If you remember one of this result, so this goes the same logic. So C0 instead of C1 C2, C0 C2 and C1 C3, right? The difference is 2. So what will be the answer? So now we have to multiply this one, C0 with the C2. That means we want x to the power n minus 2, coefficient of x to the power n minus 2. So what is that value? So 2n Cn minus 2. Okay, so that's all. You can go on writing all this result, or generally we can say that. So generally the result is this one. Okay, C0 multiplied with the sum CR plus C1 multiplied with the CR plus 1. So the difference is R here, R minus 0, R plus 1 minus 1, that is R. Okay, here the difference is 2. So if you do this one, so that'll give you the value 2nc, instead of n minus 2 here, 2 is the difference. So instead of n minus 2, we have here n minus R. Okay, so this is also one of the results. So this is the most important result, but this is also useful in many questions. So NC0, NCR, NC1, NCR plus 1, etc. So this sum has value 2nc n minus R. So the first one is a particular case when R is 0. When R is 0, C0, C0. Similarly, second case is when R is 1, 2, 3, etc. So this is the general result. Okay, so this is one of the results, right? Formula we have to remember, this you remember separately, and this is the most general case. So this is the next set of rules that you have to remember. All right, yes. We can directly write the answer to this question using the formula we have derived just now, right? So it is directly of the form, right? So this is of the form, say 40C C0 multiplied by 40C3. Next 40C1 multiplied by 40C4, etc. So this is what we need to find. See, it is like NC0, NCR. NC1, and the difference is 3 here, right? So 4 minus 1, 3. So 3 minus 0. So if the difference is 3, that means R is 3. So that means we can directly write the answer 2n, right? 2n. 2n here is 80. C, n minus R. So n is 40 here, minus R here is that difference. So that is 3. Okay, so that's all. So that is the required answer. So this is 80C 37. 80C37. So that is the answer. Or we can also write it as 80C, 80 minus 37. So that is 43. So both are correct, whichever is given, right? So 80C43 or 80C37. So that is the value, right? So if you just remember this formula, NC0, NCR, NC1, NCR plus 1, etc. So directly the formula is 2NCN minus R. So that gives you the answer 80C43. Okay. This is the most generalized result. Two different binomial series here are multiplied, right? So 1 plus x to the power n, the other one is 1 plus x to the power m, right? In the last case, so we had multiplied, so 1 plus x to the power n with the itself, right? 1 plus x to the power n, but here n and m, right? So two different sequences. Almost same idea. This is the most generalized formula, right? See, here also we have the same idea, 1 plus x to the power n. So that is n. Here we have to write the value of n. You can't simply write C0 because there are two values for this one, n and m. So we have to know the difference, right? NC0 plus NC1x plus NC2x squared, etc. So that is the first one. Next one you write x plus 1 to the power not n but m. Okay, so two different binomial series. So it is MC0 x to the power m plus MC1 x to the power m minus 1. So plus MC2 x to the power m minus 2, etc. Okay, see, almost the same idea. So here these two are different values. That's all. That's the only difference. Now we want a particular term, right? Suppose you want NC0, MC0, NC1, MC1. Then we have to multiply these terms. We will find the coefficient of x to the power m only. Sorry, x to the power m. Yes, coefficient of x to the power m. These two if you multiply, again we will get x to the power m minus 1, x to the power m. So NC1, MC1, NC0, MC0, NC2, MC2. So that is coefficient of x to the power m in this product. But we want not NC0, MC0. We want MC0, NC0, MC some other value, right? Say k. NC0, MCk. Next NC0, MCk. For example, 2. Let us take 2. MC0, MC2. And then NC1, the next one, MC3. So that we want, suppose. Then which coefficient we need? NC0, MC2, that means x to the power m minus 2. We need coefficient of x to the power m minus 2. So the next one also x, next will be m minus 3. So total will be x to the power m minus 2. So what we need is, if you want NC0, MC2, coefficient of x to the power m minus 2 is the answer, right? But not 2 here, but MCk. So that means we have to write it as, so we have to find the coefficient of x to the power m minus k in this product. This product, so it is 1 plus x to the power n. The next one is x plus 1 to the power m. In this product, you find the coefficient of x to the power m minus k. That will give you our required expression, NC0, MCk, next MC1, NC1, MCk plus 1, etc. Alright, yes. So write it. So that is NC0, MCk. That is the first term containing x to the power m minus k. Similarly, next one will be NC1, MCk plus 1. This, so that equals coefficient of x to the power m minus k in this expansion, 1 plus x to the power n plus m. Alright, if you do the multiplication of this, you will get that only, 1 plus x to the power m. So that means our required answer here is this coefficient of x to the power m minus k. That means n plus m c, right? N plus m c m minus k. Okay, so that's also, that is the value of this term. So NC0, MCk plus NC1, MCk plus 1 plus etc. Okay, so that's all. So this is a result which you have to remember. So this is the most generalized result. See, previously we derived a particular case, m and n are equal. If m and n are equal and if k is 0 particularly, then you get nc0 squared and nc1 squared etc. Now if k is not 0, okay, so k is 2 or 3 are different cases, we have done it, but here these values are also different, not the same binomial series but two different binomial series terms. Okay, so that's all. This is also one of the results that you have to remember as a formula, because many questions are there based on this result. Okay. Here also we have squares of binomial coefficients, but these terms are multiplied by these natural numbers, right? 1, 2, 3, etc. 1 multiplied by nc1 squared and 2 multiplied by nc2 squared, etc. So we want to remove these numbers, right? 1, 2, 3, etc. Similar question we have already done, right? Summation r multiplied by ncr, but instead of ncr squared is there, right? So these natural numbers multiplied with binomial coefficients we have already done, but here also we have natural numbers but squares of binomial coefficients, but the idea is same. We are going to use this method. We did by two methods, if you remember. Differentiation, we use differentiation method, and also we use this particular formula. See, we know this formula, ncr equals n by r multiplied by n minus 1 c r minus 1. So this formula we used to solve to simplify these terms. Alright, yes. Now in this question, the general term, what is the general term? We can write it as r squared multiplied by ncr squared. Okay, this is what is given actually, where r is from 1 to n. Okay, we have written in short summation form. Okay, yes. Now no r squared, sorry, just r. Okay, so r is only, right? Now this r is to be cancelled, right? How will you cancel this r? Using the same idea. So what we do, so summation r is from 1 to n r, you write this ncr as, okay, let me write it one step, ncr multiplied by ncr. So this ncr can be written as summation r from 1 to n r. This ncr can be written as n divided by r, n minus 1 c r minus 1. This is written as it is. So the same formula we have used here. Now this r gets cancelled. This n is a constant, we can take it out. So n multiplied by this summation r is from 1 to n. Okay, so this is n minus 1 c r minus 1 multiplied by n c r. So that's all. Isn't it like that formula we have derived just now? So ncr multiplied by that mc, right? mc r plus k, r minus k, right? Yes, it is like this. ncr multiplied by nc r plus k. Okay, mc r plus k, that summation. So this is what is written as n plus m c m minus k. So this is like a formula, right? So this we have derived. It is also the same type, right? So this is, in place of n we have n minus 1. Okay, in place of n we have n minus 1. So r minus 1. So r, if you substitute 1, that will become 0. First term is what? N minus 1 c 0. And similarly, this is nc1. Alright, etc. So that means it is exactly like this form. So we can directly write the answer n multiplied by. So what is the answer? N plus m. What is n plus m here? N minus 1 plus, sorry, here, n minus 1 plus n. Okay, n plus m. See, what is this difference? So that difference is 1, right? So like here the difference is k. So there we use the value k. So here the difference is 1. So that means we have to write this n, this value n, m minus k. So that means n minus k here is 1 only. So that's all. So that's all. This is the required answer, right? We have to compare what we got with the formula, right? That we are already familiar with. So what is this value? So that is n multiplied by n 2n minus 1. 2n minus 1 cn minus 1. So that's all. So this is the required answer. So n multiplied by 2n minus 1 cn minus 1. Okay, yes. Now if you don't remember this formula, you have to go back to the method which we used to derive the formula, that is the coefficient method. Okay, but we'll not do that for all the questions. We'll remember it as a formula, so that anything that resembles this product of two binomial expressions, we can use this result. Okay, so that's all. So this is the answer, n multiplied by 2n minus 1 cn minus 1. it is the same question, right? The value of n is known, that's all, right? The value of n here is 10. Otherwise, it is the same idea. See, what is given here is simply summation r multiplied by 10 cr square. Okay, so that's all. So that means, so same formula we can use. So summation here r multiplied by, so 10 cr can be 1 10 cr can be written as, so 10 divided by r multiplied by 9c r minus 1. The next 10 cr is written as it is. So 1 r gets cancelled here, right? So 10 multiplied by that sum of, okay, 9c r minus 1 multiplied by 10 cr. So same form, it is like ncr, so ncr plus k. So that difference is k and n is 9 and m is 10. Okay, so that means directly we can write the answer. So 10 multiplied by, so this is 9 plus 10, n plus m, 9 plus n, c, m, 10 minus k is that difference is 1. So 10 minus 1. So that's it. So that is 10 multiplied by, so that is 19c9. This is given to be the value of x, right? So this is given to be x. But what we need is x divided by 1430. This is what we need to find. That means 1 divided by 1430. So that is same as, so 11 multiplied by 13 multiplied by 10 multiplied by this 10, again 19c9, right? So 19c9 can be written as, so 19 factorial divided by, so 10 factorial, 9 factorial. Alright, so just a calculation here. So this, if you cancel, it is 1 divided by 11 times 13 and 19 factorial, 10 factorial. If you cancel that, so we'll get 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so this value divided by 9 factorial. 9 factorial is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's cancel some terms. So 11 multiplied by 13. So here also 11, 13. That gets cancelled. And what else gets cancelled here? So 9 multiplied by 2. Okay, 2 multiplied by 9. That is 18. So that is also cancelled. So what else? Yeah. So next one is 7. 7 multiplied by 4. Okay, or 6. If you cancel, you get 2. 2 multiplied by 14, that is 28. So 7 multiplied by 4 is also 28. So that also cancel. Okay, yes. Now next 15. So 15, 5 times 3 times 5 is 15. So that is also cancelled. So what is left? So 8. If you cancel this 8, this is 2 times. Okay, so that's all. Now what is left? 2, 17, 19. Okay, so 2 multiplied by 17 multiplied by 19. So that is the required answer. Okay, so if you do the simplification, we'll get, so 2 multiplied by 17, 17 multiplied by 19, or 18 minus 1, 18 plus 1. So 18 square minus 1, right? So multiplied by 2, 3, 20, 18 square minus, so 323. Okay, multiplied by 2. Okay, so that means, so this has a value 646. Okay, so 646. So that's also, that is the required answer, right? 646, that is the value of this. Okay, so same thing. See, this 10 cr squared, summation 10 cr squared, we know already formula, but this r is there, so we don't want this. So to eliminate this r, we use this formula. Okay, ncr equals n by r multiplied by n minus 1 c r minus 1. To remove this r, so rest of the calculations are same as the previous one. Okay, yes. Here, instead of multiplication, we have division. Here also we have squares of binomial coefficients, but divided by some natural numbers, right? So it is like ncr square divided by r plus 1, right? So what is given here is of the form summation ncr squared divided by r plus 1. Okay, so where r is from 0 to n. Okay, so this is what is given. Now we want to remove this r plus 1. How to remove this r plus 1? See, it is like this. R is from 0 to n. Now this is 1 by r plus 1. Okay, multiplied by ncr square, which can be written as ncr multiplied by ncr. Now what do we do? So like we did already, okay, in see, when you consider this ncr without square, we have done similar question to make this remove this r plus 1. To remove this r plus 1, we can combine this with this. See, multiply by n plus 1, okay, and divide by n plus 1. N is constants, you can take it out. So multiply and divide by n plus 1. Now you combine this with this, it will become, so n plus 1 by r plus 1 NCR, right? Same formula, it will become n plus 1 CR plus 1. Okay, so that is summation. R is from 0 to n, so 1 divided by n plus 1, right? Because this can only be written as n plus 1 divided by r plus 1 and 1 less than that, that is NCR, right? That is written in this form. So that multiplied by NCR. Okay, so that's all. Now it is like the formula. So we write it as, see, always write them. So that is sum of r from 0 to n, right? So among these two, the smaller one is r, that you write first. Okay, so just match with the formula. So NCR multiplied by, that is n plus 1 CR plus 1. Okay, yes. Now see, it is like the same formula. What is that? NCR multiplied by MCR plus K. NCR multiplied by MCR plus K. Again, same formula we are using. So what is the formula? N plus M C. Okay, N plus M C, this M minus K. So the same formula we are using here also. 1 divided by N plus 1 multiplied by N plus M. So N plus 1 here. C M. M is N plus 1 here. Minus K. K is that difference. So that is 1. That's all. So that is the required answer. So this can be written as 1 divided by N plus 1 multiplied by, so this is 2n plus 1. See, this is 1 gets cancelled, so n. So that's also, this is the required answer. So 2n plus 1 cn is multiplied by 1 by n plus 1. So that is the value of the expression. So to remove this r plus 1, we combine that r plus 1 with one of these NCR values. Okay, again using the same idea, right? Same formula we have used it. You can also use integration method to do this question. So that will be more complicated, right? So we have to do integration, and then we have to multiply again using the coefficient method. But instead of doing all that, just remember this formula, so we can get the answer. See what formula we use. See, this formula is important. So what formula we have used here is this one, summation NCR MCR plus K. So that equals n plus m c m minus k. So this is the formula we have used here. Okay, NCR MCR plus K. M is n plus 1. Okay, r plus k is 1. So the same formula we've used, right? So that is the formula we used here to get this answer. Okay. Here some binomial series are given in terms of determinant, right? So we have to find the value of the determinant first. It's a 2 by 2 determinant. So just in case you don't know how to expand this 2 by 2 determinant, so a determinant of this form, so a, b, c, d, so that has value this multiplication, ad minus this product, so that is c, b. Okay, so this is the value of the determinant. So we can simply do the, find the expansion of the determinant. So it is given that determinant of summation k, and this is sum of k square and ck, and similarly sum of k and ck, and sum of nck 3 to the power k. So this determinant is given to be 0. Okay, so let us find the value of the determinant. It is like a, b, c, d, like that. So that is ad minus bc. So this equals sum of k and summation nck 3 to the power k minus this product. So that is summation k and ck, and then again sigma k square nck equals 0. Okay, so each one is a known binomial expansion, right? So we know already summation k and ck, right? Like summation r and cr. So that is a formula known. Summation r square NCR, that is also known formula. This is not binomial expansion. This is like sum of all natural numbers, right? 1 plus 2 plus 3 up to n. If you substitute k value 1, 2, 3, etc. n, 1 plus 2 plus 3 up to n. So that is formula n plus 1 divided by 2. Alright, that is 1 plus 2 plus 3 up to n. That is the direct formula. And this is the binomial expansion. This is the expansion of this term 1 plus 3 to the power n. Okay, so what is 1 plus 3 to the power n? nc0 plus nc1 3 and nc2 3 square, nc3 3 cube, etc. That is what is given. So it is 1 plus 3 to the power n. That is a binomial expansion. This is a known formula, summation r NCR. Summation r NCR has formula n multiplied by 2 to the power n minus 1. And similarly, summation r square NCR. So that also is a known formula, n plus 1 to the power n minus 2, that equals 0. So all these formulas should be known, right? So summation r NCR, summation r square NCR, so these formulae are known. Okay, so that's all. Let us simplify this. What can be taken out? n plus 1, n plus 1. So that can be taken out as a common factor. So n plus 1. What else? So this is 4 to the power n, right? Here also we have 4 to the power n, right? 2, 2, 4. So 4 to the power n, that can be taken out. Then you will get 1 by 2 minus of, we have taken n plus 1 out, so this n is left, and then this 2 to the power n is taken out. Here also 2 to the power n is taken out. So from this, if you take 2 to the power n, so we will get 1 by 2, and here also we take 2 to the power n, so 2 square, so 1 by 2 square. So this equals 0. Okay, so this cannot be 0, so the only possibility that we can multiply by 2. N divided by 4 equals 0. Okay, n divided by 4 equals 0. So that gives you the value of n. So that is 4. So to find the value of n only, we did all these calculations. Okay, so that's all. So n value is known. Now we have to use this n to find the value of the expression given, right? So what is asked in the question? So that is summation, okay, NCR divided by r plus 1. So this we have to find now. Okay, NCR by r plus 1. Now n is known now, so we can use it. Now, like we did in the previous question, so we have to remove this r plus 1. How to do that? We can combine this. We can write it as, so n r plus 1 here, and NCR, you multiply this by n plus 1. Okay, multiply by n plus 1. If you multiply, you have to divide also. Okay, so this you multiply by n plus 1, and you also divide by n plus 1, so that this will become n plus 1 by r plus 1 NCR. So that can be combined. Okay, we can write it as n plus 1 CR plus 1 multiplied by, so 1 by n plus 1. Okay, because n plus 1 CR plus 1 can be written as n plus 1 divided by r plus 1 multiplied by 1 less than that is NCR. Okay, so that is written in this form. Okay, now there is no r plus 1, no r, so it is like a simple binomial coefficients, sum of all binomial coefficients. What is sum of all binomial coefficients? 2 to the power n, but here r starts from 0 to n, right? R starts from 0 to n. That means the first term is not 0 here, r plus 1. That means it starts with the NC1. That means NC0 is missing. Okay, and n plus 1 C0 is missing. That means it is not just a 2 to the power this thing. This is sum of all binomial coefficient, that is 2 to the power n plus 1 here, and the first term is missing, that you have to subtract. Okay, so that's all. Subtract the first term. First term is NC0 or n plus 1 C0, whose value is 1. That's all. That is the required answer. But we know the value of n, which is found here, 4, right? So that value can be substituted here, right? So that is 1 divided by 5 multiplied by 2 to the power n is 4, so 2 power 5 minus 1. Okay, so that is equal to, so that is 31, right? 31 divided by 5. 31 divided by 5 is approximately 6.2. So 6.2 is the required answer. We want the integer value, right? The integer part of this 6.2. So the greatest integer that is less than 6.2 is 6, right? So that is the required answer. Alright, yes. So 6 is the required answer here. See, to find the value of n only, we did all this calculation. Okay, yes. So we have to simplify. All these are known series, so we have to remember the formula. Okay, from that we got the value of n, and that n is used to get the value of this expression. Okay, that's it. So that is the answer, 6. This looks like a similar combination of the binomial coefficients, but it is not. We have to use a different method. So this question is different from what we have done so far. See, it is of the form NC0 and 2NCn minus NC1 to n minus 1 Cn. See, so far we have done questions where these values were constant, right? 2n, here also 2n, like NC0, MC1 and NC1, MC2, m only, same m here, but these values are different here. this value is reducing. So 2n minus 1, next 2n minus 2. But these values are same, right? n here, right? So it is different. So these values are same. So far we have done questions of that type only. Suppose mcn. So the next one will be mcn plus 1, something like that. So but here these values are different. So we are going to do entirely different method. Okay. So these values are okay. nc0, nc1, nc2, nc3, etc. But these second terms are only problem, right? So what we do is, see, this is done by this method. What is 2ncn? 2ncn is the coefficient of x to the power n in 1 plus x to the power 2n, correct? 1 plus x to the power 2n. From that, if you find coefficient of x to the power n, that only is 2ncn. Alright, 2ncn is the coefficient of x to the power n in 1 plus x to the power 2n. So instead of 2ncn, we write coefficient of x to the power n in 1 plus x to the power 2n. Similarly, what is the next term? Minus nc1 multiplied by, what is 2n minus 1, cn minus 1? Same thing, coefficient of same x to the power n only, because n, so same coefficient of x to the power n, but in 1 plus x to the power 2n minus 1, okay, then plus etc. Okay, so from each term is a coefficient of x to the power n only, because n here, but the power is different. Here the power is 2n and here 2n minus 1. Okay, that's it. Now let us simplify this. So from each term we only need coefficient of x to the power n, so that can be taken out. So coefficient of x to the power n in this whole thing, what is that? nc0, coefficient of x to the power n in, what is that? 1 plus x to the power 2n. So 1 plus x to the power 2n minus nc1, again coefficient of x to the power n. So this one, coefficient of x to the power n in 1 plus x to the power 2n minus 1. 1 plus x to the 2n minus 1. Okay, yes. Alright, yes. Now 1 plus x to the power 2n. Okay, now there 1 plus x to the power 2n minus 1. If you want to make it simple, let us assume that this 1 plus x equals some y. Okay, take 1 plus x as y. So we can directly also do it. So I am taking 1 plus x as y to make it easier. So what we need is the coefficient of x to the power n in, this is nc0 y to the power 2n minus nc1 y power 2n minus 1 plus etc. Now from each term we can take out a common factor, which is coefficient of x to the power n in, from this you take y to the power n out, y to the power n is taken out, so we will get nc0, y to the power n is taken out, that means it is y to the power n again, minus nc1 y to the power n minus 1 plus etc. Okay, so now it is of the form, known form, right? nc0 y to the power n minus nc1 y to the n minus 1. Next, nc2 y to the power n minus 2. That is the binomial expansion, right? So this is coefficient of x to the power n in y to the power n. This is the expansion of y minus 1 to the power n. Okay, y minus 1 to the power n, that is expansion, this only. What is the expansion? nc0 y to the power n minus nc1 y to the power n minus 1. Next, nc2 y to the power n minus 2. So this is the binomial expansion of this one, y minus 1 to the power n. Okay, yes. Now we can substitute the value of y. So coefficient of x to the power n in y is actually what? 1 plus x power n multiplied by y minus 1, 1 plus x minus 1. So that is x to the power n. Okay, so that's all. What we essentially have to find is the coefficient of x to the power n in this multiplication. But already we have x to the power n. Okay, so we want coefficient of x to the power n. That means we only need a constant term from this. Okay, so that is same as constant term, because constant multiplied by x to the power n, so that will give you the coefficient of x to the power n. So constant term in 1 plus x to the power n. What is the constant term in 1 plus x to the power n? That is the first term itself, right? 1 to the power n. The first term is 1 to the power n. That is the constant term. The rest of the terms will contain x. So the constant term in 1 plus x to the power n, so that is just 1. So 1 is the answer to the question. So that's all. So very simple, right? So that's it. So what we have to observe is this one. So when these numbers are changing, okay, then it is not of the type we have done in the previous case, right? So here these values are equal, then we can use the direct formula, but here they are decreasing, right? 2n minus 1 next to 2n minus 2, so we have to use that coefficient method. Okay, so this is the coefficient of x to power n, here also coefficient of x to power n, coefficient of x to power n, but in 1 plus x to power 2n, 1 plus x to power 2n minus 1, etc. So that's all. So that if you simplify, we get this answer 1. Okay. Here the sum of the terms of a particular series is given, that is S. Now we have to find the sum of another series which is related to that, right? So S is the value of this series, right? That is summation, right? So R is from 0 to n, 1 divided by NCR. Alright, so 1 by NC0 plus 1 by NC1, etc. up to 1 upon NCN. So that series is given to be S, right? We don't know how to find this, but its value is already given. Now using that, we have to find the value of this series, right? So sum of R is from 1 to n, R divided by NCR. So this is what we have to find, right? 1 by NC1, 2 by NC2, 3 by NC2, etc. Here R starts from 1 to n, right? Even if it starts from 0, doesn't matter, because if you substitute R 0 anyway, so we can you can write it as 0 to n or 1 to n, doesn't matter. So both have the same value. First term is anyway 0. So this we have to find. Okay, so how to find this series? Suppose this series is taken as some S1. So S1 you have to find in terms of S. So what we have to do? Okay, so what we do is, this is done by a particular method. You have to remember, we are going to replace this R. Okay, in place of R we are going to write n minus R. So you replace this R by n minus R. Will it make a difference? If you replace R by n minus R, will it make a difference? Because R is not a particular value, lot of values, a set of values. So n minus R, what are the values of R here? 1, 2, 3, etc. or even 0, right? 0, 1, 2, 3, etc. n. So these are the possible values of R. What are the values of n minus R? If you substitute R0, we'll get n. If you substitute R1, we'll get n minus 1. That means same values of R we will get for n minus R also, but maybe in the reverse order. See, R is from 0 I am taking from 0 because that doesn't make a difference here. R is 0, 1, 2, 3 up to n. N minus R has value n minus 1, n minus 2, etc. 3, 2, 1, 0. That means both have the same set of values. Okay, a particular value of R is not necessarily equal to the same value for n minus R, but the whole set of values of R is same as the set of values of n minus R. If you replace R by n minus R in this expression, so it doesn't make a difference. So what we can do is, so let me write it from 0 only, 0 to n. Okay, it doesn't matter from 1 to n or 0 to n, it will give you the same value. Now replace R by n minus R. So n minus R divided by NC n minus R. Okay, yes, done. Now, but NC n minus R is same as NCR only, because that is a known property of this NCR. So that is sum of R from 0 to n minus R divided by NCR. Okay, this NCR n minus R is written as NCR. Okay, now we can split it into two summation, right? So sum of this minus this. So this separately. So this is n is a constant, we can take it out. N sum of 1 divided by NCR. Okay, R is from 0 to n minus the second term. The second term is R divided by NCR. So that is sum of R is from 0 to n, R divided by NCR. See, that is S1. If you observe, this is what is given in the question, 1 divided by NCR sum. So that has value S. So that means this can be replaced by S. What about this? That is our question only, S1. Right, S1, whatever we have taken, that we have got again here. So that means this is S1 and this is S only. So that means we can replace this by the known series S, and this is what we have assumed to be S1. So that means, so what do you get? S1. So we are getting S1 equals, so the n multiplied by S itself. So n multiplied by S minus, again this expression is same as that S1 only. So that can be substituted here. Then we can add these two, bring it this side. So 2S1 equals NS. So that gives you the value of S1. which is ns divided by 2. So that is the value of S1 in terms of the given series whose value is S. That's all. Alright, so this is one particular type of question. So what we do here, replace R by n minus R, so that we get two series which are known, right? We have given the name to this series. So we get the same expression S1 again. So write it as S1, and this is given to be S. That's all. So we have written S1 in terms of S. So that is the answer. This is not a binomial expansion because we have three terms, 1 minus 3x plus 4x square. Only when you have two terms, we have the binomial expansion formula. But three terms are there, 1 minus 3x plus 4x squared to the power n. But we are going to use the same idea to find the relation between the coefficients. See here, the coefficients are multiplied by these natural numbers, right? 1 multiplied by nc1, 3 multiplied by nc3, 5 multiplied by nc5, etc. Not all the terms are there, only alternate terms are there. So same idea, we have to substitute 1 and minus 1, we have to add, subtract one thing, and also we have the coefficients multiplied. So we use the same idea, differentiation. So we have to use the same idea, differentiation. So what we are going to do is, so this is what is given, 1 minus 3x plus 4x square to the power n, that equals a0, a1x plus a2x squared, etc. Now to get this 2 to the front, okay, that means you have to do differentiation. Only then x square differentiation is 2x. So 2a2 you will get. So to get that, so we have to do the multiplication. Differentiation, yes, let us do the differentiation. So if you differentiate, what do you get? So to do the differentiation of this, so something like x to the power n, you have to use chain rule. So x to the power n, so that is n, 1 minus 3x plus 4x squared to the power n minus 1, nx to the power n minus 1 multiplied by the derivative of the term inside, right? So that is a chain rule. So multiplied by this derivative is minus 3 plus 8x. So that is the total derivative of the function on the left. So that is this to the power n, that is n multiplied by this, multiplied by the derivative of whatever inside the bracket. Okay, done. So this is the derivative. So here the derivative is, what is that? So a1 plus x square derivative is 2x2, 2x. So 2a2x. Next will be 3a3x square, like that. So that is the expansion. Okay, now what do? You substitute x value 1. Okay, because we don't want this x. So substitute x value 1. So if you substitute x 1, so we will get, so this is 4 minus 3, 4 plus 1, 5 minus 3, 2. So that will give you n multiplied by 2 to the power n minus 1, and this is 1. So 8 minus 3, that is 5. So that equals, so a1 plus 2a2 plus 3a3, okay, plus 4a4, etc. Okay, so like that you will get. But even this one is not required because we only need these odd values, right? a1, not a2, but a3, and then a5, etc. Only odd values. So we want to remove these values. What do we have to do? Same idea that we've used already here. So x you can substitute minus 1. Okay, if you replace x by minus 1, we get another expression. So that is n multiplied by, so minus 1, that means 4 plus 1, 5 plus 3, 8. So 8 to the power n minus 1, and here if you substitute minus 1, so that is minus 11. So that equals, now here alternate minus plus, right? First term is positive, second term is negative. Minus 2a2 and plus 3a3 minus 4a4. Okay, so like that. So now you have to add these two. If you add this, a2 will be cancelled. Here also a4, so that gets cut. So that means, so you will get what is required. So add these two. So adding these two, so if you add, we'll get, what can you take out as a common factor? So n, and you can even take 2 to the power n out. 2 to the power n minus 1 can be taken out. So we'll get 5 minus 11 multiplied by, so 2 to the power n minus 1 is taken out. Okay, so 8 can be written as 2 multiplied by 4. So 2 to the power n minus 1 is taken out. So 4 to the power n minus 1. Okay, multiplied by 11. Okay, done. So that equals 2 times our required answer, that is a1 plus the third term. So 3a3 next one will be 5a5, etc. Okay, so that's all. So this is the sum we need. So that equals, so just to divide this by 2, that's all. So that implies our required answer, a1 plus 3a3 plus 5a5, etc. So that equals, so divide this by 2, so it will become n multiplied by 2 to the power n minus 2, okay, dividing by 2, and this will be written as it is. So 5 minus 11 multiplied by 4 to the power n minus 1. So that is the required answer. Whether it is basic binomial expansion or whatever expression given, the expansion of that is given, you can find the relation between the coefficients using the same idea. Maybe you can't use the formula directly because it is not binomial expansion, but the idea is same, right? Same idea. So differentiate it to get this multiple, and also substitute 1 minus 1 to get alternate terms. So that's all. So same idea we use to get this answer. Okay. So far we have done only questions of single variable, right? The summation is over only one variable, right? R ranges from 0 to n, etc. Right? Now we have two variables, double summation, right? So one summation is for one variable and there is also another variable, right? R and k. One summation is for R ranging from 0 to n. Similarly, the other value k, that also ranges from 0 to n, right? Double summation questions, that's what we are going to do now. Okay, yes. Now what is given? So that is okay. One summation is for R is from 0 to n, and k is also from 0 to n, NCR, NCK. Okay, yes. Now this is the first type of question which is very simple, because this R and k are not at all related. There is no relation. They are independent variables. So that means this summation over k does not affect this NCR. The NCR is over R only, not k. It is more like a constant for this summation. Okay, for constant you can take it out of this summation, right? So that means it will become sigma k r. R is from 0 to n. You can take this NCR out because that is constant for this summation. So that is NCR, and this as it is k from 0 to n. So that is NCK. Now it is a simple formula, right? Now it is a single summation only. This is a summation. So this is a summation which you know. What is summation R from 0 to n? NCR. That is sum of all binomial coefficients. So that is formula 2 to the power n. That's it. This is also the same type. Summation k from 0 to n, NCK. Same sum of all binomial coefficients. So that is also 2 to the power n. So that's all. So we can write 2 to the power 2n, or we can say 4 to the power n. So 4 to the n. So that is the value of this thing. No relation between r and k. So one summation does not affect the other variable. You can take it out and then we can get the answer, right? 4 to the power n, that is the value of this expression. This one looks similar to the last one, but here the variables r and k are not independent. One depends on the other. R must be less than k. So we can't do these two summations separately. Alright, see here also summations 0 less than equal to r less than k less than equal to n. So that means r must be less than k. We can't do these two things separately, NCR and NCK. Alright, so now this is done by a different method. What is the meaning of this? See, let us take the first one. R is 0. If R is 0, K cannot be 0 because K must be greater than R. K may be minimum 1. See, like NC0, NC1, NC0, NC1. Similarly, NC0, NC2, NC0, NC3, etc. Now R is 1, NC1, NC2, not 1, NC1, NC2, NC1, NC3, NC1, NCn. Now if R is 2, NC2, this will start from 3 only, NC3, etc. So it is like this. A few terms we will write. It's not possible to write all the terms. So it is like this one. See, first NC0, NC1. If the 0, this is 1 only. It cannot start from 0. Next NC0, NC2, etc. Suppose R is 1. So NC1, NC2. Like that it will go on. These two values will never be equal and we cannot interchange this. These two are different values. Okay. Now it is like the product of two terms of the binomial, right? Two binomial coefficients multiplied and then added, sum. So this is what is denoted by the symbol. For our convenience, we will denote this by the symbol S2. What is S2? Sum of terms taken 2 at a time, sum of product of values taken 2 at a time. See, we have this formula, that's what we are going to do. This is one of the methods, okay, so we can do it by other method also, writing this in the matrix form, and then we can pick the terms which are relevant to us, but this method seems to be easier, right? So a plus b plus c, a plus b plus c squared. What is a plus b plus c squared? So that is a squared plus b squared plus c squared plus 2 ab plus bc plus ca. Okay, this is the expansion we know, but it is not only true for 3 numbers, it is true for even 5 numbers. If it is 5 numbers, so we can write a square, b square, c square, d square, e square plus 2 times a, b, b, c, c, a, e, f, all combination. That is what is S2, taken 2 at a time. This is sum of values. Okay, this is sum of values. We can take sum of a square. Okay, for convenience we are writing like this. Now this is sum of the squares of terms plus 2 times, this is taken 2 at a time. Let us denote this by S2. Okay, S2. So S2 is what? Sum of product of values taken 2 at a time. Okay, so from this we can write S2 equals the sum of all values, summation a minus sum of a square divided by 2. So this one can be used as a formula to find the product of values 2 at a time, something like this. So this S2 is what we need to find. So from that formula, what is S2? So that equals sum of all values. Which values here? Sum of all NCR, right? So that means here S2, this S2 is sum of all NCR. That means sum of all NCR R is from 0 to n the whole square. Okay, that is the meaning of this sum of all values minus sum of squares of values. So that means sum of NCR square. Okay, so this whole thing divided by 2. So that's it. So this is the required answer, but this value is known. This is also known to us. So what can you do? What is sum of all NCR? That is sum of binomial coefficients. That is 2 to the power n. So this 2 to the power n and power 2, right? 2 to the power n the whole square minus, this is also a known formula, sum of squares of binomial coefficient, nc0 square plus nc1 square up to ncn square. That is also known formula, 2ncn. So this whole thing divided by 2. So that's all. So this is the value of the given series. So that's it. So remember to use this formula if two binomial coefficients are multiplied and then added, all similar terms. So then we can use this idea. Okay, S2 equal to this one, sum of all values. Yes, that's all. So this is the answer. You can write it as, okay, so we can write it as, if you want, 4 to the power n or 2 to the power 2n, right? So 2 to the power 2n minus 2ncn divided by 2. So that is the required answer. Okay, yes. So that's all. So that is the answer. Again, we have a double summation over two variables r and k. R is less than k. NCR, NCK. Not only that, so some values are multiplied, right? R plus k is multiplied. So our aim is to remove this r plus k, right? So like we usually do. So this r plus k was not there. Then this question is similar to the last one. So we have to remove this r plus k. How will you do that? See, this is what is given. R plus k. NCR, NCK. If this value was not there, then that is the question we did already, right? So this thing you should remove. Okay, how will you remove that? So what we do, let us take this sum to be S. Okay, S is what we need to find. Okay, let us find S. So what do you do? We have already used the similar method in one question. What you do, replace this R by N minus R and replace this K by N minus K. Will it make a difference? Only the order will be reversed. Okay, only the order will be reversed because R has value 0, 1, 2, 3, etc. And N minus R also has value minus, right? So N, N minus 1, N minus 2. So same value, but order is reversed. But this time R is not less than K. K will be less than R, right? This becomes smaller now. Okay, so because from N we are subtracting bigger value, so that will become smaller. So, but order is reversed. So this is when R is less than K. Okay, so what do you get if you simplify this? Here k is less than r, whatever order, but all the terms you will get, even if you replace r and k by these values, n minus r, n minus k. Okay, so what will that become? So n minus r plus k is n minus k, and NCR is NC n minus r, and NCK is written as NC n minus k. Okay, done. So that becomes this n plus n, that is 2n, minus r minus k. So that means minus of r plus k, and NC n minus r can be written as NCR only, right? That is the property of NCR, and similarly NCK here. Now we can split it into two summations, right? Like a double summation of 2n, this value, and then r plus k, the same value. So the first term is this one 2n, again summation of whatever there. So NCR, NCK, done, minus of the second term. Second term is r plus k summation, right? Double summation. R plus k, NCR, NCK. Okay, yes. So that's all. See, this is what we have found in the last question. Remember, so we have to use the same expression, right? Because we have already done it, let us use the result directly. Okay, so we can directly substitute what we have derived in the last question. Okay, NCR, NCK, where r is less than k, that we have derived, I think something like this one, 4 to the power n minus 2ncn divided by 2. Because we have already done it, we are using that result. Otherwise, you have to do it separately. Minus, what is this one? This is double summation r plus k, NCR, NCK. That is a given question only. R plus k, NCR, NCK. Same question only. That is what we have taken as S. So this is S. So that is equal to S itself. Okay, that means we can simplify to get the value, right? That's all. So 2S equal to this value. So we can get S. That's all. So this implies 2S equals, yes, so this gets cancelled, 1, 2 gets cancelled, which means n multiplied by 4 to the power n minus 2ncn. So that gives you the value of S, that is n by 2 multiplied by 4 to the power n minus 2ncn. So that's also, this is the required answer, right? So this particular idea we have already used, right, in some question, right? Same idea we use here, but here two variables, but you do the same thing here. So n minus r, n minus k. Okay, then we are getting the same series again. Combining that, we get this result. Okay, so n by 2, 4 to the power n minus 2ncn. That is the answer to the question. We are done with the properties of binomial coefficients. Here is a list of formulae for your reference.